Okay, so we're recording the second hour. Let me go back. Sharing the slide. Get this way this time. All right, so where we left off was all this if stuff, and and we talked about what if if the grade was 70. We want to skip over the if statement. Yeah, we want to skip over the if statement that if the grade is not greater than 90. We want to skip over if it's greater than 80. If it is 70, we want to get into that. Right? But what if we want like multiple conditions? We want to kind of share conditions. We don't want to have to use multiple if statements. Like if, for example, if teacher is, if the call is still going on and the teacher is talking, then I want to pay attention or something like that. Like I want to have an and or an or something like that. Right? So we have some logical operators we can use. We have, remember I said before, the not equal, this exclamation point. So we have the not operator, which basically changes a true to a false, false to a true. Now, if we put a variable in there, it does not change the variable's value. Okay. Another question. Okay. Okay. If we have a variable that's true, for example, and we put the not operator in front of it, it does not change the variable's value from true to false. It just gives us the result of that expression is now false, okay? So again, it does not change the variable value. Not true does not change true to false. It just changes the result of the expression to false. I'll show you some examples. Maybe some examples will help you understand that better. Okay. There's this and operator. Notice it's the 2 ampersands. It's the double ampersand. I think Dokkan showed us an example of that in the chat right before the end of the first hour here. A good example of that, where and, right? So if the thing on the left and the thing on the right are both true, then the result of an and is true. If either one of them is false, then the result is false. Okay. Again, this is not saying anything about the two things on either side. It's just testing whether or not they're both true. Okay. So for an example in real life would be if I am going to class and I'm going to eat lunch, right? If I don't do either of those things, then I've said a false statement, right? Only if I do both of those things is it a true statement. Okay. Now, or is this double pipe, what we would call the pipe or vertical line. Again, just like with the and, you need 2 of them. Okay. This one says that if either the thing on the left or the thing on the right are true, then the result of this is true. If both of them are false, then the result of this is false. Okay, this is what's called an inclusive or. Sometimes we just refer to it as or. Actually, usually we just refer to it as or, but its meaning is inclusive. So what it means is if, like I would say, I will go to class, or I will do something else, or I will eat. An example I said a second ago. Right. Now, if I do both of them, then it's still true. Okay. It's a little bit harder for us to understand this inclusive or in English, or I don't know about in Turkish, but in English, because so oftentimes we use or in English and in talking in this exclusive or fashion, where it means either one or the other, but not both. Okay. This or means either A or B or both be true. This exclusive or, this hat kind of symbol, this upside down V looking symbol, it means either A or B but not both. So they have to be opposite. True, exclusive, or false is true. False, exclusive, or true is true. If they are the same, if they're both true or they're both false, then the result of this will be false. So it would be in English, we would say, either I'm going to class or I'm going to the cinema. I can't do both, right? I can't go to class and the cinema at the same time. Okay. Right, exactly. Like XOR, for anyone that's done any digital systems type of studying, XOR, exactly. The X stands for exclusive, right? Correct. Alpair and M right there. Okay. Dokkan, no, you don't need the two hats, you just need the one. So unlike the and the or, the exclusive or just requires the one symbol. Okay. Again, for some people who have done some programming in the past, there's some languages that this symbol is the exponent function. So you would have the exponent operator, so you would have a to the power of b. That's not in Java. Java, the single hat. Okay, I got you. An emoji. Sorry, guys, I'm older. I keep being told by my students that only old people like me use Facebook. So, you know, I'm not up on all the emojis. So, all right. What was I saying? Oh, so in other languages, this could be the exponent, a to the power of b. In Java, this is exclusive or a or b, but not both. Okay. Here are just some examples. The next, what we call a truth table. So when we have an expression, right? So what is the result of that? So we have a variable, a, b, c, and so forth. Then an expression and the result of that expression. Okay. So here, P1, P2. Notice all combinations here, false, 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 true, true, false, true, true. And the result of that, notice it's only true if both of them are true. Here, or the truth table shows us that it's only false if both of them are false. It's true for all other combinations. Exclusive or, it's only true if they are opposite of each other. False, true, true, false gives us true values. False if they are the same. Okay. All right, so we'll look at that example during the third hour. I have this one queued up and ready to go. Some examples here. Okay. So I do want you to know about this. So there is a difference between the single ampersand and the double ampersand. Okay. One is called, so one tests the first expression, right? And if, well, I didn't know do that. Okay, and if it's true in this situation, sorry, if it's true, then it will test the other one. Okay. If in the other examples, I can't remember the special name for it off the top of my head. I'm sorry. So if this is false, then is there any need to test this? Right? And the answer is no, right? There's no reason to test the second half of this if this one's false, right? Now, why is this important? Well, in an example like this, this test also includes doing something to x, right? This x plus plus, right? So if this is determined to be false, right? And we don't even execute this part because why should we, right? False and anything. And the reason why this is important is because if this is not executed, x doesn't change its value. Okay. Again, I'm blanking on the special name for this. Let's see. Short circuit. It's okay. The short circuit operators. Okay. Okay. So it's called a short circuit operator. So basically, with a single ampersand like this, it will test this, and if this is true, then it will test this, which would result in the changing value of x. Okay. So generally we use these, right? I don't see these, the single ampersand or the single pipe. I don't see them in practice very often, but they can be useful. Okay, they can be useful especially if you have a really long, let's say instead of like 1, 2 here, let's say you had a long string of conditions, if this and this and this and this and this, all right, and you wanted to be able to if this first one was false, not even bother with all the rest, then it can be useful in that situation. Okay, I think one of you wrote that. Yeah, Al Perry said optimization, right? Exactly. It can be optimal. It can also, if you have something like this where you only want x to increase, if the result of this was true in the first place, then this could be important that way. Okay. All right. This one is a very fun one. We will do this one in the third hour also, the leap year calculation, right? Because we are in a leap year actually this year, so that's good. And so you find out that this is a leap year. The lottery example is out there. It's in the examples folder. Lottery. I do not encourage you to play the lottery. I think it's not very wise to do so, but it is a good example for us to look at for programming, for randomly generating numbers and being able to see how close we can get to them and stuff like that. Okay. All right. One thing I said I was going to introduce to you guys earlier in today, I said this switch statement. So there's a couple of not just if. We don't have to use if statements for conditionals. Sometimes for what's called discrete things, we can do switch statements. Okay. So we can have a variable, right? And the type of variable that can come in here can be anything discrete. And what that means is anything like an integer, anything that can have an exact value that we can compare to. As we saw in the previous set of slides as an example there, double numbers we don't get to do that with, right? We can't say 1 minus 0.1 minus 0.1 minus 0.1 minus 0.1 minus 0.1 is automatically always going to be exactly 0.5. And that the reason for that is because of the way that, I'm going to slow down, because of the way that double numbers are stored in computers. Unfortunately, we cannot compare them to exact values the same way we can with integers. All right, so the status here, this variable or this expression in here has to be an exact value that we can compare to. So it can be an integer. It could be a character, because a character is stored using ASCII coding, which is integer based. It could be a long It cannot be a float. It cannot be a double. It could be a Boolean, but with a Boolean, if we put a Boolean in here, it's basically just an if statement, right? Okay, so let's see how a case statement might work, right? So one thing I want to point out, this break must be there at the end of a case, and you'll see why in just a moment. But what happens is that if the status is 0, we execute this line, these lines, and then we break. And the break is like an else. So we break out of the whole thing. Case 0, case 1, case 2. So if status is 0, we do this. If status is 1, we do this. If status is 2, this. 3, we do this. Notice each time we break. Break is, like I said, like an else. Break says get out of the block that we're inside of. And this is going to be important when we do loops in 2 weeks, that the break is saying not break out of this case. What the break is saying is break out of the control structure. That was the word I was looking for earlier, right? This is a type if statements, switch statements, loops are types of control structures. We're controlling the flow of the program. Okay. So break says, get me out of the control structure I'm currently most inside of. Okay. So if this switch were inside of another if or inside of another switch, the break would not break me out of the whole thing. The break would just break me out of the switch. Okay. Common practice is to have a default of some kind. If we don't have default down here, even though we may know that it cannot possibly be another value, even though we may know we've programmed it in such a way that it's going to be a 0, a 1, a 2, or a 3, it cannot possibly be something else. We will still get not a compiler error, but we will get a compiler warning that will tell us you might not have accounted for all cases. And the reason why is because computers, we are doing lots of work with artificial intelligence, but they still can't be smart enough to be able to look at a situation like this and know if you've covered all cases or not. Okay, I hope that's clear. All right, so this would be the flow chart. Notice it's very similar to an if, right? If this is true, do this. If this is true, do this, so forth, and end up all linking together based at the end of this switch statement and move on. Okay. Like I said, we have to have an expression that is, I can't remember the special word. I say discrete or exact. And so it could be char, byte, short, int. It could also be a long. Okay, I think it can be a long. All right. The values for the different ones. Just like with an if statement, if it could manage to be true for 2 different ones, right? It's whatever the first one we come to. Okay, that's the one that it's going to be. All right, the break should be used at the end of each case. It's optional, and if it's not there, we're going to see what's going to happen in just a moment. All right, the default is again also optional, but we may get a compiler warning if we don't use it. So here's an example where we don't use break. Right? We don't use break for some of the cases, and what's going to happen? Okay. Now, suppose the day is 2. What's going to happen is we're first going to check and see, is it equal to the first case, right? Does it match case 1? And the answer is no. So we're going to skip over case 1. It's going to match case 2. Now, case 2 has no lines of code in it, but also no break. So what's going to happen is it's going to fall through case 3, through case 4, through case 5. Oh, now I see a line of code. I'm going to print that out. Right? I'm going to encounter the break, and I'm going to get out of my control structure, out of my switch. Okay. Now I want to make sure we're clear on what just happened here. It matched one of my cases, but there were no lines of code there and no break. And the most important part of that is the no break, because it executes whatever's here, which is no lines of code, and then it continues on. And even though it doesn't match case 3, it's still going to execute those lines of code because it hasn't gotten to a break keyword yet. So then it's going to go into 4. It has not gotten a break keyword yet. It's going to go to case 5. It encounters a line of code. It's going to display this. It's going to execute that line of code. All right. So it's going to print weekday. It's going to have break. It's going to break out of the control structure and be done. Okay. So notice this is days 1, 2, 3, 4, 5. Monday, Tuesday, Wednesday, Thursday, Friday, which are weekdays. So now let's suppose the day was 6. Okay. Does it match case 1? No, so it skips over that. Does it match case 2? No, so it skips over that. Does it match case 3? No, so it skips. 4? No, so it skips. 5? No, so it skips. Even though there are lines of code here, it hasn't matched a case yet. So it's going to move on. Does it match case 0? No, so it skips. Does it match case 6? Yes. So it's going to print weekend because 6 is the number for Saturday. And there is no break statement, but that's okay because we don't need to have a break statement because it's the end of the switch. Okay. If we had a default case down here that maybe displayed invalid day or something like that, then we would want to have a break here. Okay. Oh, did somebody have a question? Oh. Yeah, exactly. Some of you guys are helping out with the answers there. We put 0 here because 0 is Sunday, and 6 because this is based on the week starting on Sunday. So Sunday is the 0th day of the week, right? And so 0 is part of the weekend. I hope that's clear. Yeah. Makes so much more sense for the week to start on Monday. My son keeps telling me, I don't understand why Sunday's called the weekend. It starts the week. It doesn't make sense. All right. All right. You can look at this one. We won't do this one in class, but it's an interesting use of switch statements. Okay. One more new way to do this whole conditional expressions, instead of using ifs or switches, is this what's called a it's called a ternary operator, or binary operator. So let's say you had a situation where it was just a simple if statement. If x is greater than 0, I want to set y to equal 1. Otherwise, I want to set y to equal -1. Okay. So I have one condition, I have one variable, and I just want to set its value based on the result of this condition. Right? We can do that using a conditional expression like this. Okay, where if x is greater than 0, we give a value of 1. Otherwise, if x is not greater than 0, that's what this colon means, we give a value of -1. And this expression, then the result of this, so if it's greater than 0, we give a 1. If it's less than or equal to 0, we give a -1. The result of that 1 or -1 is then used as an assignment to y. Okay. There are some other examples of how we can use this, where instead of assigning a variable's value, we can actually have expressions over here. So x is greater than 0, system.out println something, otherwise system.out println something else. All right. We can use this in a lot of different powerful ways, but it's just a single expression here. So it's just, if it's like some single line of code, some easy stuff, right, then that's what we do here. Okay. We can cascade these or nest these just like with if statements, where we put this operator inside of something that's inside of this, and we can keep that going. Just like though with that tree structure I talked about, if, else, if, else, if, else, it can get a bit confusing if we nested them too deeply. Okay, but they can be useful if we have just some simple conditional single line of code type stuff. Okay. All right. So an example of how to convert this, right? If however we test for if a number is even, right? We print num is even. Otherwise, we print num is odd. Well, wouldn't that be nice if we could just have one single print line command and then just test, is it even? And if it is, we display our value is even. Otherwise, our value is odd. Right? So we can put that inside of a print line as the result of a print line. Okay. So basically the conditional operator, Boolean expression, question mark, expression 1, colon, expression 2. If this is true, we execute expression 1. If this is false, we execute expression 2. Okay. One final thing, a couple final things I want to go through here with you. All right, is some precedents. Like, so we talked about last week, we talked about mathematical precedents where multiplication is done over addition, right? So if there's 3 plus 5 times 6, right, we do the multiplication first and then we do the addition. Right? Well, now we have new operators that we have to take into account. So we need to figure out how they're all done, right? So basically this is the order, right, of all the operators that we've talked about so far about how the precedence will be done. So this first, this, then this, then this, then this, and so forth. The main thing I want you to know, the main thing I want you to remember, one is that this logical operator is going to come before any of these mathematical operators. But then we're going to do all these mathematical things. And then we're going to do relational operators. Okay. Less than equal, greater than equal, equals, not equals. And then once all of these result in true, false values, we're going to do exclusive OR and then OR. Right? Note that and has precedence over OR. So just like multiplication takes precedence over addition, and takes precedence over OR. That's very important. Okay? And then finally, once we have a value, we can do assignment operators at the end. Okay? So this is going to be the final thing that we do, is if there's an assignment involved, we do it. Okay? Parentheses, make sure we do whatever's inside of parentheses first, right? Do we have that? Okay. Parentheses are the ultimate. Anything inside of parentheses is going to be done first. Okay? All right. So here, notice we go left to right in mathematical operators. Right? So A minus B is done first, plus C is done next, minus D is done last. Assignment operators are the other way around. So we would do C equals 5 plus E, then we would do this assignment operator second, then we would do this assignment operator last. So in other words, we don't do A equals B first. What we do first is C equals 5. The result of this is this value. So it's as if we put 5 into this plus equals assignment, augmented assignment operator. So now B is going to be equal to plus equals whatever B was before, plus 5 is the new value of B. That's going to be the value that's then put into A. Okay? So at the end of this, C is going to be equal to 5. B is going to be equal to whatever it was before plus 5. A will be equal to the new value of B. Okay. So one example here, how we would do this. We do what's inside of parentheses first. So 4 plus 3 gives us 7. Okay, now we go left to right doing multiplications. So 3 plus 4 times 4. Oh, we got a multiplication. So 4 times 4 is 16. Got another multiplication. 5 times 7 is 35. Okay, so now we go left to right doing addition. 3 plus 16 is 19. 35 minus 1 is 34. 19 is greater than 34 is our final operator. It's false. 19 is not greater than 34, so it's false. And the final of this expression is just false. Okay. Again, this does not cause an error. This does not cause any type of compiler or logical error. This is entirely just a test for if what is on the left side of this greater than symbol is greater than what's on the right side of this greater than symbol. Okay? And what we come to is false. Skip over that for just a second. Look through the debugging thing. Most of you have IDEs that have debuggers. It's a very useful tool in an IDE to be able to step through code, line by line, one by one, to be able to find bugs, right? Logic errors are called bugs, and that actually comes from the first computers actually had a moth in the system that caused the problem. And that's why they're called bugs today. And so back when I was learning computer programming many years ago, we didn't have debuggers. So we just had to, if we got a logic error, just have to go either read through the code over and over again until we found it, or we would put a lot of what's called got here statement. We would print, print got here. And if you printed the got here, then you knew, or you might print a value. If I was expecting a variable to have a value of 5, I would display a message that says, A equals 5 or A equals whatever, and then display the value of A. And if it was 5, I would say, okay, well, good, I got the value I'm expecting. But we had to put a lot of lines of code like that in there back in the old days. Days that you have debuggers are very useful. Get used to how to use them, how to set breakpoints, step through line by line, and see how things work. Okay? All right. One thing I want to leave out this hour with, okay, so this time, I want to go ahead and put these out there. Let me do format, okay? All right, so here we have 4 examples that I've put in here that will all, make it a little bit bigger for you to see. Oh, not too big, okay? All right, now what I want you to do is I want you to respond in the chat what you think these are. Is this false or true? Is this false or true? All of them will result in a Boolean value, either false or true. In the future, when I do examples like these, I might not give only false or true. I might give, one might be a Boolean, one might be an integer, one might be a double, and so forth. Okay, but for today, all of these are going to be false or true. So go ahead and respond in the chat. I'll leave this up. I'll stop the recording because those who are watching this as a recording are able to pause the video. But go ahead and pause the video if you're watching this afterwards. If you are on this live call, use this break time to answer the questions and see what you think. All right. So what we'll do is we'll break here and we'll start up again in 14 minutes at 11:20. 20 is what I have, is what time we'll start up again. Okay.